AP Calculus BC Unit 5, Day 7, Office Hours. You should have checked your answers already. Here they are real quick. Pause the video if you need to. This is the first page of answers. Here's the next problems, 7, 8, 9. Pause the video if you need to. And the last ones. All right. Let's do these. Now, we're using integration by parts on a lot of these. I'd be writing this list lipit every time next to problems, but maybe you write it once, like with more details. Log, inverse, trig, polynomials, polyexponentials, expo, trig, regular trig. So that's what the letters stand for. Remember to try other integration techniques before you try something more complicated. So this first one, we can't integrate any other way. So this is poly, this is expo. Remember there's a shortcut for polyexpo, polytrig. So we have lipit and we have polyexpo. So there's a shortcut. I'd be using the shortcut on this. You don't have to, but it's going to save you a lot of time. The shortcut is you take the derivative of the polynomial until it goes to 0. The other one you integrate. E to the x, e to the x, e to the x. You do plus, minus, first one's positive, alternate sign, and you go down on a diagonal. So the answer is going to be x squared e to the x minus 2x e to the x plus 2 e to the x plus c. That's it. Okay, number 2, poly, trig, lipit, poly and trig. We can do the shortcut. Do the shortcut. So 3x squared, 6x, 6, 0. Keep going all the way to 0. Positive, negative, positive, negative, positive. The antiderivative of sine x is negative 1/2 cosine 2x. Next one's going to be negative 1/4 sine 2x. Next one is going to be positive 1/8 cosine 2x. And the next one is going to be positive 1/16 sine 2x. So we're going to go down a diagonal. The answer is going to be negative 1/2 x cubed cosine 2x. Next one is going to be positive 3/4 x squared sine 2x. Next one's going to be positive 3/4 x cosine 2x. Next one's going to be minus 3/8 sine 2x. And don't forget the plus c. Okay. Next one. Nope, can't do with U-Substitution. Go do lipit. We have Polylog. No shortcut. First one lists as your u, the other one's v prime. So this one got to do it the regular way. So u equals natural log of x, and then v prime equals x squared dx. Take the derivative, get 1/x dx, integrate, v equals 1/3 x cubed. So we write it uv 1/3 x cubed natural log of x minus the integral of the two new things. I'm going to put the 1/3 out in front. It's going to end up being x squared, right? 1/x times x cubed. So we should, the idea here is that this new integral is now something that you can integrate. So it's going to be x cubed over 3 plus c. Let's write it nicely. 1/3 x cubed natural log of x minus 1/9 x cubed plus c. Okay. Let's try the next one. Next one has Polyexpo, Lipit. Polyexpo is a shortcut. You should use it. Otherwise, it'd be a terrible problem. Okay, so 3x squared, 6x, 6, 0. This is going to be 1/4 e to the 4th, e to the 4x. This is going to be 1/16 e to the 4x. This is going to be 1/64 e to the 4x. And this is going to be 1 over, what's 4 times 64? 240, 256 e to the 4x. Positive, negative, positive, negative, positive, add a diagonal, tic-tac-toe. Okay, so the answer is 1/4 x cubed e to the 4x minus 3/16 x squared e to the 4x plus 3/32 x e to the 4x minus 3/128 e to the 4x plus c. So that's a shortcut. Way fast. Super fast. Okay, next one is Expo Trig. So Lipit. Expo Trig, no shortcut. Whatever's first, it's going to be u. Next one's v prime. So u equals e to the x. V prime equals sine 3x dx. U prime equals e to the x dx. V equals 1/3 negative 1/3 cosine 3x. Anti-trig. So we're going to write it. UV, so we negative 1/3 e to the x cosine 3x minus the integral of the two new things, which has a negative 1/3, which I'll put in front, e to the x cosine 3x dx. Plus plus. But we can't integrate that. I guess we got to do it again. Now this is like that problem I showed after the warm-up. There's a couple of these in the last assignment. You should get the feeling that this is never going to get better, but let's use that against it. Next time, we're going to get what we start with. We'll just move it over there, do that. But we got to do it again for sure. So we have Expo Trig. Expo comes first. That's your u. Trig's v prime. So u equals, I'm going to just put the 1/3 in front of the integral. I'm not going to bother with that right now. So u equals e to the x. V prime equals cosine 3x dx. And you take the derivative. Integrate. Rewrite it. Negative 1/3 e to the x cosine 3x minus 1/3, actually plus 1/3, parentheses, all this stuff's got to go in parentheses. 1/3 e to the x sine x uv minus the integral of the two new things, and put the 1/3 in front, e to the x sine 3x dx. So that's what we have so far. Here's the thing. These match. So we're going to bring them together. We got to distribute this 1/3. So it's going to be -1/9. So we're going to add 1/9 to the other side. We're going to get 10/9 e to the x sine 3x on the left equals -1/3 e to the x cosine x cosine 3x plus 1/9 e to the x sine x. And then the other stuff's been moved to the other side. So we're going to write plus e. So we're going to multiply both sides by 9/10. Distribute it. So e to the x sine 3x dx equals -3/10 e to the x cosine 3x. Distribute this. 1/10 e to the x sine x plus c. Don't distribute the 9/10. So that's it. There should be a 3 right here, though. I somehow lost that 3 in the process. That's not good. Okay. That should have 3 also. Okay. Looks good. Okay, next one. You might start to recognize these. You might be like, oh, whenever there's like Expo and Trig, it just goes in circles. Right? Expo and Trig, you got limit. You got Expo and Trig. No shortcut. So whatever's first is your U, V prime. So U equals e to the ax, V prime equals cosine bx dx. So this one has some extra variables in it. They're just constant, so we can just treat them like numbers. So u prime equals ae to the ax dx, and b equals 1/b sine bx. Right, antiderivative. Okay, so the answer is going to be two new things: 1/b e to the ax sine bx minus the integral of the two new things. So I'm going to move the a over b out front, and then e to the ax sine bx. And unfortunately, I don't think we're going to integrate this, so we got to do it again. So Expo, Trig, this should be u, this is your v prime. So u equals e to the ax, v prime equals sine bx dx. So I'm going to take a derivative of this, a e to the ax dx, integrate this, plus equals -1/b cosine of bx. Okay, so what do we have now? 1/b e to the ax sine bx. Now this all has it's going to be minus a over b parentheses uv -1/b e to the ax cosine bx minus the integral of the two new things. So there's -1/b in front, a over b in front, and you have e to the ax cosine bx dx. Now, we are finally back to where we started. So we're going to move that to the other side. Now we have to distribute these. Negative a over b to that, which would be positive a squared over b squared. So if I move this to the other side, I will have 1, and then this is going to be positive, so minus a squared over b squared e to the ax cosine bx dx. equals 1 over b, e to the ax sine bx, plus a over b squared, e to the ax cosine bx plus c. So now we just need to divide both sides by this, 1 minus a squared over b squared. It might be good to try and, change this to where it's not a complex fraction. So this is the same thing as b squared minus a squared over b squared. And so then we can multiply by the reciprocal, right? Let's just make sure I'm doing this all right. So this had an extra negative, so that should be positive. So this should actually be negative, so we should have added it to the other side. Okay. All right. So I think we have our answer. E to the ax cosine bx dx equals 1 over b e to the ax sine bx we could, distribute this b squared. So this would end up being just b. And then this would be plus a e to the ax cosine bx, because the b squares would cancel. And then it would all be over a squared plus b squared. And there would be a plus c. There you go. So these are a little challenging. But I think you guys can get the hang of that. All right. Let's do some more of that. Okay, number 7. Now, it says partial fractions. You need to start just recognizing these because they're all going to get mixed up on the test. So, can we use any other techniques? No. Is the degree of the top smaller than the degree of the bottom? Yes. So, I think we're going to use partial fractions. So, we got to factor this. Plus 3 minus 2. So, this is going to be a over x plus 3 plus b over x minus 2 dx. So we're going to multiply through by the least common denominator and get 5x plus 5 equals a x minus 2 plus b x plus 3. Plug in negative 3 first if you want, or the other way around. It'd be negative 15, so it'd be negative 10 equals negative 5a. So a equals 2. Then we can plug 2 in everywhere, and that's going to be 15. 15 equals 5b, so b equals 3. So now we can rewrite it. 2 integral of dx over x plus 3 integral of dx over x minus 2. So it's going to be 2 natural log of the absolute value of x plus 3 plus 3 natural log of the absolute value of x minus 2 plus c. Now let's combine these together. So we're going to bring these inside. They have to have the same coefficient or just no coefficient. They're going to end up getting multiplied. So natural log, this one we could replace with parentheses because it's getting squared, right? And then times, this one we still need the absolute values. And then plus c. So all this stuff is inside the log, natural log. I mean, this is technically an answer, but I'm just telling you, they usually combine them. Okay, next one. If it works, I think we do partial fractions. Degree of the top smaller than the bottom. So we get a factor at x over x squared plus 1. So this equals a over x plus b over x squared plus 1 dx. So we're going to multiply through by the least common denominator. Again, we could get rid of b right away, and b5 equals a. But we can't get rid of a. Nothing. So we just have to live with it. Plug 5 in. I'd pick 1 to try and get x. So now that's going to be 5, 5. This is going to be 13 equals 10 plus b. So b equals 3. So sometimes you can't totally get rid of the terms. All right, so we're going to rewrite it, break it up. It's going to be the integral, I'm going to put the 5 in front, dx over x plus 3 dx over x squared plus 1. This is going to be 5 natural log of the absolute value of x plus 3 inverse tangent of x plus c. Done. Okay, next one. Next one, we can't do partial fractions because the degree of the top is equal to the bottom. It needs to be smaller than, not greater or equal. So we have to do long division. So long division is going to be 5x squared plus 32x plus 51 divided by x squared plus 6x plus 9. We're going to start with the first ones. That's a 5. You distribute, so 5x squared plus 30x plus 45. We're going to subtract this. You get 2x plus 6. This is the remainder because the degree of this is now smaller than the denominator. So you're done long division. So we're going to rewrite it. And we have 5 and plus 2x plus 6 over x squared plus 6x plus 9. Now we're going to do partial fractions. I mean, let's see what happens. Let's take a 2 out. That might be helpful. I don't know. Probably not. X plus 3, x plus 3. Ooh, this is a repeated root. So we got to do some special stuff for that. So it's going to equal a over x plus 3 plus b over x plus 3 squared. So we're going to multiply through by the least common denominator. So we get 2x plus 6 equals a x plus 3 plus b. So we're going to plug negative 3 in to get rid of the a's and find the b. So that's going to be 0 equals b. So b actually equals 0. You know what? We could have done U-Substitution right here. This is going to work, but it's just unnecessarily hard. So I'll go back and show you in a second. Now we're going to plug that in. Then we're going to plug, say, negative 2 in. And so we get 2 equals a. So it's kind of weird because this is going to be 2 over x plus 3 plus 0 over x plus 3 squared, which if you get 0, that probably means you didn't need to do it, okay? Because this is what we have now. Now, if we had done U-Substitution on this, we would probably say u equals x squared plus 6x plus 9, du equals d equals 2x plus 6 dx. Oh, that's perfect. So then you would replace it with the integral of du over u. Let's see if it gives the same answer. It should be. So I'm going to go back to doing it this way. So we have integral of 5 dx plus 2 times the integral of dx over x plus 3. So it's going to be 5x plus 2 natural log the absolute value of x plus 3 plus c. So that's the answer. We could also write as 5x plus natural log of x plus 3 squared. Right? That works. If I go back over here, what do I get? I get natural log of the absolute value of u. So I get, if I integrate this, I get 5x, and then when I integrate this with U-substitution, I get natural log of the absolute value of u, which is x squared plus 6x plus 9 plus c. And guess what? You're like, oh, that looks different than this. Actually, if you were to expand that, it'd be x squared plus 6x plus 9. Now, I've gotten rid of the absolute values because I realized that came from something squared, so it really should be positive. In fact, on this one, I think anything you plug in is going to always be positive, so you can just drop the absolute values. But that was a little quicker. We didn't actually need partial fractions. U-substitution up working. We need to do long division for sure. Okay, these ones. Always have U-substitution in mind. du equals 2x dx. Perfect. So it's going to be 1/2 cosine u du. So that's going to be 1/2 sine u plus c. So that's going to be 1/2 sine x squared plus c. Not bad. Okay, next one. We could try U-substitution. 9 minus x is 6th. Hopefully in your head you're starting to see that they don't work. Like that one's not going to work because we need x squared. Well, then maybe it's that like inverse sine thing, but this needs to be a 1. So we're going to need to factor a 9 out of everything in the bottom. It's actually a square root of 9. So then we still have a square root of 1 minus x is 6 over 9 dx. This is where your u is going to go. It's going to be x cubed over 3, right? So u equals x cubed over 3, du equals x squared dx. It's perfect. So this is going to be 1 over 3 by the square root of 9 is 3. Du over square root of 1 minus u squared. So it's going to be 1/3 inverse sine of u plus c. So it's going to be 1/3 inverse sine of x cubed over 3 plus c. All right. And here's another one. I don't think you can factor this. We should do long division because they have equal degrees. So it's going to be x squared plus 0x plus 5 divided by x squared plus 0x plus 1. So when we start with the first terms, it's a 1. Distribute x squared plus 0x plus 1. Subtract. And we get 4 for the remainder. So the answer is, it's going to be the integral of 1 plus 4 over the remainder. So the answer is going to be x plus, this is going to be inverse tangent. You guys need to recognize it. All right, last one. Natural log of x, we didn't memorize it. Maybe we've seen it a couple times now. This is actually, I think, the third time we say, oh, okay, let's trick it. Let's make it look like, integration report. Polylog, lipit. So we have polylog, no shortcut. So the first one in the list is your u, the other one's your v prime. So u equals natural log of x, v prime equals 1 dx, u prime equals 1 over x dx. We integrate this, b equals x. So what we have now is we have uv x natural log of x minus the integral of the two new things, 1 over x times x dx, which ends up just becoming 1. So we get x natural log of x minus x plus c. There you go. All right. Well, I hope you guys are getting good at these. That's it for this assignment.